Hello, this is the Class 9 video, and in this video we're going to be talking about three processes: conversion, obversion, and contraposition. And yeah, I know, the Latin names are awkward and weird. Obversion is probably not a word you've encountered before, but the kind of logic that we're studying grew out of the European tradition, and all the people who were studying it used Latin as their lingua franca, their shared language. So in case, what these three things are, we call them immediate inferences. They are ways that you can get from one kind of statement to another. But before I begin explaining all of that, I want to just review where we are. So in the first three chapters, we talked about sort of logic in ordinary language. We just read passages, sometimes they could be even from newspapers or books, and we wanted to see if there was reasoning in that passage, whether there was an argument, and then we could represent that argument in standard form. What's happened more recently is we've started trying to standardize the language that we're using. And so we've been calling it logically structured English. And it's sort of a midway point between a fully formal logical language and ordinary speech. So what we've been doing is we've been taking a whole bunch of ordinary English sentences and trying to represent them as what belonging to one of four kinds of sentences. We call these the moods, right? So the mood A, the moods are A, E, I, and O. Mood A statements are anything that can be represented as all S, R, P. And we represent that with the Venn diagram that you see here, where you've shaded the part of S that's not P, indicating that nothing can go there. So the only legitimate S's are also going to be in the P circle. And what we found is actually a surprisingly large number of English sentences can be put in this box. They all ultimately function like statements that say all S are P. So a sentence like all dogs are mammals works that way. And that one's obvious because you've got the all and the R, so you just turn S into dogs and P into mammals. But other things are like this too. All lions are fierce lions are fierce without the all turns out to be this way, and that means we say that the all is implicit, and we'd say something like all lions are fierce creatures or something like that. If a dog scratches on the back door, it wants to be let out, is actually an all SRP. All dogs that scratch on the back door are dogs that want to be let out. Chewbacca is a Wookiee, is an all SRP. All things identical to Chewbacca, all aliens identical to Chewbacca are Wookiees, something like that. In any case, the exercise up to this point had been about trying to cram a whole bunch of different kinds of English statements into these four boxes. And these are all things that you can cram into the box A. Box E is things of the form no S are P. You represent it with the Venn diagram where you shade in the overlap between S and P, indicating that nothing can live there. Nothing can be both S and P. And so these are sentences like, no dogs are reptiles, or penguins cannot fly, or even, we are never, ever, ever getting back together, or if something is a dog, it is not a cat, right? Mood I was some S are P. This would be a sentence like some dogs are friendly, some dinosaurs had feathers. Most mutations are harmful counts as this because we turn most into some. One president has been African American because we turn one into some. And to do this, we have our Venn diagram, and then we put an X in the center, indicating that something exists in the overlap between S and P. So our fourth box is just is mood O. Some S are not P. So you have the X in the section that is S but not P. It's in and the X is that says that something lives there. And so that could be some dogs are not pets, some birds cannot fly, most snakes are not dangerous, one person does not like spaghetti. So that's where we are. And really what's happened is we have now gotten to the point where we can just talk about these four abstract statements, all SRP, no SRP, etc. And what we're going to do with these abstract statements is begin to manipulate them and see how it affects the validity of different arguments. So the most straightforward manipulation that you can do is actually just switch the subject and a predicate of a sentence that you're given. So if you're given something that says all S are P, you can change that to all P are S, right? All S are P, that becomes all P are S. If you had no S are P, that would become no P are S. If you had some S are P, that would be some P are S. If you had some S are not P, you have some P are not S. So right, that's pretty straightforward. All you've done is move two letters. You switch the S and the P. S and P are variables. They stand for terms in English, right? So we could also talk about doing this with sentences that have English words instead of S and P. So you might take a statement like all dogs are mammals. Now remember, this is true, right? Just mammals are the class of animals that includes dogs and cats and rodents and stuff. So all dogs are mammals. If you take the converse of it, if you use conversion, this statement becomes all mammals are dogs. Now notice what happens here. This is a false statement. So conversion has changed a true statement to a false statement when you are using A statements, that is, statements in the mood A. But now think about another sentence, no dogs are reptiles. This is also true, right? Look at all the dogs in the world. Think of my dogs, Cupcake, Sprinkles. They're not reptiles. Your dogs are not reptiles. No dogs are reptiles. If you flip this one around, you get no reptiles are dogs. But this is also true. So in this case, conversion, just switching subject and predicate, has a different effect. In one case, it turned a true statement into a false statement, and in another case, it preserved the truth value, right? So you can see this actually in the Venn diagrams. This is the Venn diagram for all S are P. We have shaded the region of S that doesn't include the overlap. And that means that any X you try to draw will have to be in the middle, where it will also be a P. If you change this statement to all P are S, you get a diagram that's flipped around. Now we want to shade the region of P that is not S. And that means that we it's impossible for something to exist in that circle. You try to draw an X there, you'd have to draw it in the overlap. But notice these are just different sentences. All SRP is, the diagram is for all SRP is different than the diagram for all PRS. So you can see how this would turn a false statement, a true statement into a false statement. On the other hand, consider no SRP. This is the Venn diagram for no SRP. You shade the overlap. If you change it to no PRS, you're still shading the overlap. The Venn diagram is the same after you use conversion. What this shows is that that conversion preserves the truth value. The true statements remain true if they are E statements and you flip subject and predicate. So this means that we can have some arguments that are invalid and others valid based on whether or not you are based on the process of conversion. So if you start with a statement, the premise, all S are P, and you try to conclude the sentence, all P are S, the resulting argument is invalid because you have moved from a statement that could be, if your premise is true, your conclusion could be false. We saw this with the dogs are mammals example. And remember the definition of the word valid. An argument is valid if it is impossible for the premises to be true and the conclusion false. But in this case, it is possible for the premises to be true and the conclusion false. Right? So this is an invalid argument. This is an invalid argument. There we go. But we can actually make substitutions here that leave the premise and conclusion true. So if you say S is dogs and P is Canis familiaris, you'll have an argument that looks like this. Premise, all dogs are Canis familiaris. Conclusion, all Canis familiaris are dogs. True premise, true conclusion. That's fine. An invalid argument can have true premises and a true conclusion. It means that format also has situations where the premise is true and the conclusion false. And that's what we get with the dogs are mammals example. When you make S dogs and P mammals, you see all dogs are mammals is true, but all mammals are dogs is false. So this argument is invalid because some of the time when you substitute things in for S and P, you get a true premise and a false conclusion. That doesn't happen all the time with all the things you can substitute for S and P. It doesn't happen with dogs and Canis familiaris, but it does happen with dogs and mammals. Now let's go back to thinking about no S are P and no P are S. You can imagine an argument that says no S are P, and from that you conclude no P are S. This time the argument is valid, right? So you put in dogs and reptiles. No dogs are reptiles, and no reptiles are dogs. Those are both true statements. You move from a true premise to a true conclusion. But actually, no matter what you put in for S and P, if the premise is true, then the conclusion will be true. So if S and P are chairs and monsters, you get the premise, no chairs are monsters. And then you get the conclusion, no monsters are chairs. Well, the premise is true and the conclusion is true. So you cannot create a argument here where the premise is true and the conclusion false. Therefore, this process of switching subject and predicate creates valid arguments for statements of mood E. Something similar is going on with our particular statements, right? So in mood I, you have some S or P. That means you draw an X in the middle. If you do conversion, you switch subject and predicate, you get some P or S, and you still have an X in the middle. So those arguments are valid. On the other hand, with O statements, some S are not P. When you switch subject and predicate, you get some P or not S. The X is now on the other side. So that doesn't work. So again, here are the diagrams for what happens when you switch subject and predicate for all four kinds of statement. All S or P is invalid because the Venn diagram changes. No S or P is valid because the diagram stays the same. Some S or P is valid because the diagram stays the same, and some S or not P is invalid because the diagram changes. So again, you can look at it like this. If you go from all S are P to all P are S, the truth value might change when you do that conversion. So therefore, the argument is invalid. For the next two, the truth value always stays the same, so the argument is valid. And then for O statements, again, the truth value could change, and therefore the argument is invalid. So that is the first of the three transformations we are discussing, right? The first transformation was conversion, and all conversion means is switching subject and predicate. The two other things that we're studying this class are obversion and contraposition. But to understand obversion and contraposition, we need to add one more bit of vocabulary, and that's the term a complement. Complement. So a complement is the class of anything that is not in a given class, right? So you imagine a shape. The complement of the shape is everything outside that shape. So if you think about if our class, our first term is dogs, then the complement of that is non-dogs, everything that's not a dog. And that includes cats, tables, the number 2, the idea of love. All of those things are non-dogs, so they belong in the complement of the class dogs. Similarly, the opposite of the complement of cats is non-cats. And in general, for any S, the complement is non-S. So if S is represented by shading S, shading the complement of S would mean shading everything that is outside of S, right? So that's how you implement that with the Venn diagrams. So once we have the idea of a complement, we can talk about our second process, obversion. The obverse is a statement formed by changing the quality of another statement and then taking the complement of the predicate. What does that mean? Well, you start with a statement like all dogs are mammals. You represent it with this Venn diagram. Now, if you wanted to change the quality of the statement, remember, quality is whether it is affirmative or negative. Quantity is whether it is universal or particular. So if you're changing the quality, you are changing the affirmative to a negative. That means that the resulting statement is no dogs are mammals. That's represented with this Venn diagram. And now we've turned a true statement into a false statement. But look what happens when you do the last part of this transformation. You take the complement of the predicate. What you get are no dogs are non-mammals. And now, so you're saying nothing in the category dogs is outside the category mammals, and you're back here again. So with an A statement, taking the obverse, that is changing the quality and then taking the complement of the predicate, preserves the truth value. And it turns out that this is true for all four kinds of statements. obversion, taking the complement, changing the quality and then taking the complement of the predicate always preserves truth value. So here are some arguments. All S are P, therefore no S are non-P. That is a valid argument. No S are P, therefore all S are non-P. That is a valid argument. Some S are P, therefore some S are not non-P. That's awkward, but it's valid. Some S are not P, therefore some S are non-P. It's valid. So essentially what we're doing here is a kind of double negation. When you change the quality, it's a negation, but taking the complement of the predicate is also a kind of negation. So this kind of argument is always valid. The last process we want to look at is contraposition. The contrapositive is a sentence that is formed by switching subject and predicate, just like you did with conversion, but you take the complement of each. So you start with a statement like all dogs are mammals. Now it has this Venn diagram. You switch subject and predicate, and you get all mammals are dogs. That's this diagram. And as we saw before, we've turned a true statement into a false statement. So that showed us that conversion didn't work on the statement, all dogs are mammals. But for contraposition, we do conversion and then another step. That other step is taking the complement of both sides. So what we get are all non-mammals are non-dogs. It's a mouthful, but it turns out to be exactly equivalent to the original statement. Right? So for contraposition, the situation is the reverse as it was for conversion. For conversion, E and I statements, conversion led to valid arguments when applied to E and I statements. This time around, the valid arguments are the other two, A and O statements. So here are our four arguments by contraposition. All S are P, therefore all non-P are non-S. That's valid. On the other hand, no S are P, therefore no non-P are non-S is invalid. Same with the particular argument beginning with the premise some S are P, but not the same when you begin with some S are not P. So all arguments using contraposition are valid for A and O statements. Okay, so for the homework for this time, you start out just by applying these three transformations, conversion, obversion, and contraposition, to different statements. Then you keep track of whether or not it changes truth value for them, and then for finally the third section, you evaluate arguments. And then that's it for today's class.